These extraordinary blades are an iconic symbol of the Viking Age.
It's a dedicated calculating machine.
Before today's technology existed, ancient innovators forged tools and secrets so advanced that modern science still struggles to explain them. Scattered across deserts, oceans, and ruins, their creations hint at knowledge far ahead of its time. Today we return to these 10 mysteries, not to solve them, but to understand how they reshaped our history, and why their secrets may still lie dormant, waiting for us to catch up. Number 10. The Wedge of Aiud. Discovered along the Mureș River in 1973, the Wedge of Aiud remains one of archaeology's strangest puzzles. A chunk of aluminum-like alloy resting beside Ice Age bones, long before humans learned how to smelt aluminum. Some dismissed it as misplaced machinery, but its thick oxide layer and disputed dating sparked debates that never fully cooled. The object's slanted geometry resembles a mechanical component, yet no known tool or device matches it. And complicating the mystery further, researchers at the Romanian Institute for Metal Physics once reported that the wedge's alloy contained trace metal ratios not used in any Romanian industrial casting process, suggesting a material source outside local manufacturing history. After a brief museum display, the wedge vanished, leaving photographs, measurements, and decades of speculation behind. Number 9. Greek fire. When Greek fire first erupted from Byzantine warships in the 7th century, enemies described it as a liquid flame that clung to wood, water, and even armor. A weapon so terrifying that its very sight caused fleets to scatter. Its formula was guarded so fiercely that even rival empires failed to reproduce it, and the substance became a cornerstone of Constantinople's survival for centuries. Ancient manuscripts depict pressurized siphons mounted on ship decks, spraying inferno across the waves. But the technology went far beyond simple flames. Historical accounts from the Tactica suggest some vessels carried rotating bronze siphons, an early form of gimbal-mounted weaponry, allowing crews to track moving targets even in rough seas. The Byzantines didn't just invent a formula, they pioneered naval firepower centuries ahead of its time. Number 8. Damascus steel. For centuries, Damascus steel blades were said to slice through lesser weapons, bend without breaking, and hold edges so sharp they bordered on myth. Their swirling surface patterns hinted at secrets buried deep within the metal, secrets lost entirely by the 1700s when the original methods disappeared. Warriors prized these blades not only for beauty, but for performance unmatched in battle, and modern metallurgists have tried relentlessly to reproduce the effect. Yet each attempt falls short. Under powerful electron microscopes, researchers discovered something extraordinary inside authentic Damascus samples. Tiny carbon nanotube structures, meaning ancient smiths unintentionally forged nanocomposite materials long before nanotechnology existed. How they achieved such uniformity remains unknown, making every surviving blade a relic of an engineering breakthrough humanity has yet to fully understand. Number 7. The Antikythera mechanism. Pulled from a shipwreck off a Greek island, the Antikythera mechanism looks at first like a corroded mass of gears, until its complexity becomes impossible to dismiss. Dozens of bronze cogs once turned in perfect harmony, tracking celestial motions with a precision no other known device would match for over 1,000 years. Scholars believe it predicted eclipses, charted planetary cycles, and even modeled lunar phases on a hand-cranked display. Its inscriptions, revealed through modern imaging, suggest it was both a scientific instrument and a teaching tool, built by minds steeped in mathematics and astronomy. A recent computational reconstruction went even further, showing the mechanism accounted for the moon's non-uniform orbital speed, a feat not formally rediscovered until Kepler. Someone in antiquity mastered that calculation long before the rest of the world caught up. Number 6. The Iron Ashoka Pillar of Delhi. Standing quietly in Delhi for over 1,600 years, the Iron Ashoka Pillar defies the usual fate of exposed iron. Monuments of similar age crumble to flakes, yet this pillar remains astonishingly intact. Its surface smooth, its structure solid, its corrosion minimal. Historians often attribute this resilience to exceptional craftsmanship, but the deeper mystery lies within the metal itself. Ancient Indian metallurgists blended high phosphorus wrought iron with remarkable consistency, creating a material that responded unusually well to centuries of monsoons and heat. Modern analysis revealed something even more surprising: a thin passive film of iron hydrogen phosphate hydrate, a self-forming protective layer that prevents rust from advancing. Without knowing it, the pillar's creators engineered a corrosion-resistant alloy that continues to outperform many modern steels. Number 5. The Baghdad Battery. On the surface, the Baghdad Battery looks deceptively simple: a clay jar, a copper cylinder, and an iron rod sealed in place with asphalt. Yet, when filled with an acidic liquid, it produces a measurable electric charge, an ability that predates any documented battery by more than a millennium. Its purpose remains a subject of debate. Some propose electroplating, others argue it served ritual or medical functions. What's clear is that the Parthian craftsmen who built it understood far more about chemistry than their written records reveal. Recent imaging of similar vessels uncovered abrasion marks showing the metal rods were repeatedly inserted and removed, implying regular maintenance and reuse. This wasn't a one-off curiosity. It may have been part of an early workshop practice where electricity was a tool, not a mystery. Number 4. The Ulfbert Sword. Forged at the height of the Viking Age, Ulfbert swords stand apart from every other weapon of their time. Their blades were astonishingly pure, flexible, and resilient, so advanced that medieval metallurgy simply shouldn't have been capable of producing them. Yet, more than 170 authentic examples carry the same enigmatic inscription, suggesting an elite workshop or guarded lineage of smiths. Tests show these blades held far higher carbon content than typical Viking iron, approaching the quality of modern steel, and they performed with a reliability that made them legendary among warriors. But the greatest surprise came from laboratory analysis revealing precisely controlled phosphorus levels, meaning Viking craftsmen selectively sourced and purified specific bog iron deposits. They weren't just forging swords, they were practicing early materials engineering centuries before industrial science formalized it. Number 3. Zheng Heng's seismoscope. In 132 AD, Zheng Heng built a machine so strange that early scholars doubted it could have worked at all. A bronze vessel adorned with dragons and toads that somehow detected distant earthquakes. When seismic waves traveled through the ground, an internal mechanism triggered a dragon's mouth to release a bronze ball into the waiting toad, indicating the direction of the tremor. No gears survive, no diagrams remain, and yet, historical accounts insist the device functioned with astonishing accuracy. Court records even describe an incident in which the seismoscope signaled an earthquake over 400 miles away, days before riders brought the news. 17 centuries before modern instruments, Zheng Heng created a mechanical sensor whose sensitivity engineers still struggle to replicate. Number 2. Roman concrete. Across the Mediterranean, Roman harbors, temples, and seawalls stand with a defiance that modern concrete rarely achieves. Their structures have endured earthquakes, storms, and centuries of salt water. Yet the secret wasn't brute strength, but chemistry. Roman builders mixed volcanic ash, lime, and seawater in a recipe that produced a material capable of healing itself. When cracks formed, minerals crystallized and rebound the fractured surfaces, making the structure stronger over time. Samples taken from ancient piers near Pozzuoli revealed even more remarkable behavior. Aluminum tobermorite crystals continued forming for centuries, turning the concrete into a slow-growing geological composite. Instead of deteriorating, Roman concrete evolved, adapting to its environment. It's an engineering philosophy modern construction is only now beginning to revisit. Number 1. The wrinkled stone. At first glance, the wrinkled stone looks like a geological impossibility, a block of granite folded and creased as if it were soft cloth. But unlike every other entry on this list, this marvel isn't ancient at all. It was carved by Spanish sculptor José Manuel Castro López, whose precision and intuition blur the boundary between illusion and reality. López studies each stone until he understands its internal tension, then works along stress lines to coax impossible shapes from unyielding minerals. His creations demonstrate how easily a skilled artisan can make nature appear supernatural. And the most revealing insight is this. He achieves many effects by carving along anisotropic fracture planes within granite and quartz, meaning an ancient craftsperson with similar instincts could have produced equally baffling works. The line between mysterious artifact and masterful illusion may be far thinner than we assume. Across continents and centuries, these technologies reveal how much our ancestors achieved with so little, and how many answers still evade us. If these mysteries fascinated you, share your thoughts below, subscribe for more deep dives, and join us as we explore the hidden chapters of our world.